So we are going to discuss about Module 3 next session term to be as hypothesis testing. So in this session, we are going to discuss about what is hypothesis testing, how it works, why we are going for it, and steps of hypothesis testing, and some sort of examples then and there. So hypothesis testing is something which is present in statistics. So in descriptive statistics, it is nothing but where you are going to identify what you're going to do with the collected randomly sampled informations from a raw population or large population. So hypothesis testing is an act, simply it is an act in statistics where as an analyst you are going to do some sort of assumptions regarding an population parameter. So the methodology employed by the analyst depends on the nature of data which is used and the reason for the analysis. This is simply called as hypothesis testing. How it works is an analyst tests a statistical example or a sample with some sort of goal for providing evidence for the set. So testing an hypothesis by measuring and examining a random sample population is something which is done inside this hypothesis. So there are two different type of hypothesis information. One is null and another one is alternate. So when coming towards null hypothesis, it is stated that this population is going to mean as something. So the mean got through this random samples is going to return 0. This is called to be a null hypothesis. Another one type is called to be an alternate hypothesis, where it is going to state that population mean is not equal to 0. So these two hypotheses, which is called to be as a null and alternate hypothesis, are mutually exclusive. So one can be true at a time and another one could be false. So this is how it works. So analyst is going to find out something. They are going to examine something with the random samples what they have collected. Either the answer can be null hypothesis or the answer can be alternate hypothesis. So I hope you got some sort of better understanding of what is hypothesis testing and how it works in statistics. I think you can able to understand. So this is nothing but a act, statistical act, or we can call it as a method used for inference to decide whether the data collected by the researcher or by the individual is sufficient enough to support a particular hypothesis. So this test allows us to make some sort of probabilistic statement at the end about the population parameters what have been calculated from the raw data set. So steps in hypothesis testing are as follows. Each and every hypothesis testing consists of 4 step process. So the first step is that analyst is going to state the two hypotheses, either null or alternate, so that only one could be right. The next step is that analyst is going to formulate and plan, which is going to outline how the data will be evaluated at last. Third step is the analyst is going to carry out the plan and physically they are going to analyze the sample data. Fourth and final step is that the analyst is going to analyze the results and with the help of the result, either they are going to reject the null hypothesis or state that the null hypothesis is okay for the given population. So these are the 4 steps. First step, we are identifying two hypotheses, whether it is null or alternate. At step 2, we are evaluating the outlines. At third step, we are going to physically analyze the sample data. At fourth and final step, we are going to either reject the null hypothesis or we are going to confirm the final hypothesis with the given data. So step 1. Step 1 is defined as null and alternate hypothesis. So in this hypothesis testing, you are going to have a parameter term to be as H0 and HCA, where H0 is called as no difference, HA is called to be as difference. H0 is called to be as null hypothesis, HA is called to be as an alternate hypothesis. So in this example, we are going to have some sort of problem where we are having the year to be as 1970s. In that there is some sort of raw data where men's are having age between 20 and 29. So you're going to have the mean value to be as 170 pounds for the men. So and a standard deviation is 40. So if a researcher thinks that he and she needs some sort of changes, so for the information what they have got, they will go for this hypothesis testing, whether to reject or whether to confirm the data what they have collected from the random samples. So in this case, they will go for checking whether the mean population mean is returning zero or the population mean is doing some sort of changes. If there is no change, it is called to be as null hypothesis, because in this problem we are having the mean value to be as 170 pounds. So in null hypothesis we are getting the same information to be as 170. So it is coming under null hypothesis. If it is going to have some sort of changes, if the average mean value of pounds is to be as above 170, so it is called to be as an alternate hypothesis what we have got. So we can go for a step one in this, whether we could change or whether we are in need of some sort of increase or no change, like that. Step two. So after doing that, step two is termed to be as locating the critical region. So we are going for identifying the accuracy in the information what we have got, either from null hypothesis or from alternate hypothesis. We are going to identify whether we have got the level of accuracy what we have uh, desired, or the precision of what we have desired. So there are two sort of variation. One is termed as likely, and one is termed as unlikely. So we have to locate the appropriate critical region from where we are going to collect the samples. So in this graph, we are having some sort of smooth approximate curve. The distribution of samples is present in this curve. If the null hypothesis is true, all the possible outcomes will be present. So your sample mean is close to null hypothesis, where it is holding the higher probability of if H0 is true. That means the population mean is 0. So your range is going to be from extreme low to another extreme low. So these are going to be the outliers. So here we are having two sort of bar blue lines, which is going to throw the outliers for us. So the layer present between these two blue bars is termed as critical region. So we can locate the critical region in such a way that we can outlier or we can cut out the outliers, which is having some sort of extreme low less than 0, like that. So this is a sample mean which is close to null hypothesis. So we are having three sort of alpha ranges. If alpha ranges is 0.05, so your range could be from minus 1.6 to plus 1.6. So this is going to be your critical region. If your alpha is going to be 0.01, if your range is going to be from 0.258 to minus 0.258 to plus 0.258, then if your alpha is going to be 0.001, it will be from minus 3 to plus 3. So these are the ranges. So according to the alpha value, the critical region will be located. So it will have the extreme boundaries of both positive and negative ranges. Then step 3 is we have to calculate the z-score. So the definition of step 3 is computing the test statistics. So you are going to compute the test statistics and you are going to find out what is a z-score. So z-score is nothing but a ratio between the obtained difference between the sample mean value and hypothesis to mean value what we have got from the previous sector. Sample mean is something which we will be getting through the normal mean identification, and hypothesis to mean is something which is different, where we are identifying the hypothesis mean value from the population parameter what we have collected. Then third step is we are computing the information. We are finding the difference between the original sample mean and hypothesis to mean. So this is a z-stat is something which is called as an z-score. So you have to know the information of only something which is called to be as an samples what we have collected, there is n value and standard deviation. Then we have to know what is the mean information. That is the thing. So which is having mean 0 is nothing but where you are stating that you are going to consider the hypothesis to mean information to be null hypothesis. That is the thing where we can state that population mean parameter is going to return 0 for us. So this is a simple example, which is a previous example what we have seen. So here we are having the same information and we're calculating the Z stat value. So this is a Z stat value what we have got. Our sample is 64, n is equal to 64, standard deviation is 40, and our mean is 170. So they have given the hypothesis to mean to be as 173. So you are getting your Z stat value to be as 0.60. So the next one, with this we are going to draw a conclusion. We are going to have two sort of difference in drawing conclusion. Either you will get larger value or you will get smaller values. If it is going to be larger value, so the difference is significant, we can reject the null hypothesis. If it is going to be small, the evidence is not sufficient to make any sort of confirmation, so it will fail to reject the hypothesis to mean value. So these are going to be the ranges which can happen in any sort of examples. So probably 5% will be the value which is significant for any sort of examples. So this is a summary of the session what we have seen. Hypothesis testing is something which is used to assess the falsity of hypothesis what we are going to use from the sample data. We are going to provide some sort of test for concerning the mean value what we have got. By this information, analyst is going to identify whether they can confirm or reject the information what they have got. Thank you.